Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've shown that in a log-log model, the slope coefficient beta 1 is an elasticity, so in this video, let's apply that to a worked example. Suppose that we estimate a demand model that looks like the following. ln of Q equals to 5.2 minus 1.3 ln of P, where Q is quantity demanded and P is the price. So I know for a lot of you that might have done a little bit of econometrics, if you look at this, you think of issues with the model, but keep in mind, this is just for example purposes, and we're not going to talk about the assumptions behind this particular model. So the most important part in here is that both variables are in logs, so the slope is an elasticity. The beta 1 hat in this case is minus 1.3, which means interpretation-wise, we're going to say that a 1% increase in price is associated with a 1.3 decrease in quantity demanded. Okay, so the negative sign matters because it tells us the direction. So as a reminder, even though you have log-log model where all of the numbers that have been logged have had to be positive because the log of a negative number does not exist, that does not mean that the beta that we estimate here cannot be negative. So now let's apply the rule like a 10% change. So that means the percentage change in quantity, right, is going to be approximately equal to minus 1.3 times the percentage change in price. So if price increases by now 10%, that simply means that the percentage change in quantity is simply minus 13%. So a 10% price increase is associated, so here this is associated with a 13% decrease in quantity demanded. Okay. Now, the absolute value tells you more about the sensitivity. So if since in this case 1.3 is larger than 1, we can sort of deduce from here that demand is elastic, which means quantity responds more than proportionally to price. Let's look into a positive case. Let's say we have a model where we've got ln sales equals to 1.1 plus 0.6 ln of ads, where sales is how much sales you get out of a certain product and then the advertising that you do to it. Interpretation-wise, our beta 1 hat in here is just 0.6, which means that a 1% increase in ads is associated with a 0.6% increase in sales. Okay. And if, let's say, ads increase by 20%, what that will mean for us is that the percentage change in sales is going to simply be 0.6 times 20% being 12%. Okay, so a 20% increase in advertising will be associated with about a 12% increase in sales. So in a log-log model, remember, you do you do not need to multiply by 100 or divide by 100. The coefficient is already in percent per percent terms. So if you've got the 0.6, it just means 0.6% change. So you don't need to turn it into a percentage and say 60%. Okay. So log model, beta 1, the elasticity, and you take it as it is in percentages. Hope this was helpful, and I'll see you in the next video.